Hey everyone, it's Mr. Richards here, and I'm going to be talking about our assignment for the week of March 8th through the 12th. So we're going to be working with a tank again, and to review quickly, a tank, or any vehicle that has treads on it, has non-turning wheels. That means there's no steering wheel that turns the front wheels or the back wheels to cause the vehicle to change direction. Instead, what we use is two motors, and those motors control each side or each tread independently. And so in order to move forward, both motors need to be moving forward at the same speed, and to move backwards, both motors need to be moving in reverse at the same speed. If we want to turn, we need one motor to move forward and one motor to move reverse. That would be a spin. And if we want to do an arc, or sort of a turn like a car would turn, then one side would move faster than the other side, and we get the tank to move in sort of an arc or a circle. Alright, so all of that is the same as we've done before. This week we're just adding a 180 degree turn. There's a really important thing in here that I want you all to be aware of. And it's tough to kind of explain or show it because we're not actually programming robots at this time, but if we were in the classroom, it'd be very obvious right away. Anytime we change the motion of the robot, we should add a 1 second pause. And the reason we do that is because as the robot moves forward, it has momentum. And if we cause it to stop and immediately turn, it's going to, that momentum can't disappear, and it's going to want to continue moving forward, and we can get these things to roll over, we can make the motors break, they can slide, they can do all sorts of things that we don't want them to do. So it's important when we cause a change in motion that we give it like a 1 second to kind of slow down and stop before we change the direction, okay? And so that's shown in this desired behavior. We'll do this for a couple of assignments where I say, I put the 1 second pause in the desired behavior. After this, I'm going to be expecting that adding that pause in there is something that you just do, and we don't have to have it in the desired behavior. So anyway, so here is our desired behavior today. Move the tank forward at full speed for 10 seconds, stop for a second, turn 180 degrees, stop for another second, and move forward at full speed for 10 seconds. Now, since this tank has turned 180 degrees, this final move forward for 10 seconds will actually be returning it to the starting point. And I've also added in here a 180 degree turn requires one motor to run forward at full speed for a second and the other to run at reverse in full speed for 1 second. So this is how we're going to do that 180 degree turn. Here are our motor commands. So what I'm going to do is I'm going to copy this desired behavior over to my robot programming, and you would be doing this on a Word document. You could do this in a Google document. It doesn't really matter what you do it in, but my suggestion is do it somewhere where you're not writing it directly into Schoology, because you can get mistakes and errors and stuff. So alright, so I have to go through a couple extra steps because I need this to know that I've got a motor. And motor L. And if you were in the classroom, we would be doing this. This part of this just is telling the computer that there are two motors on this thing. And I got to make sure that you can make mistakes really easily. Okay, so I've got a motor R, which stands for the right motor, motor L, which stands for the left motor. I'm going to click apply, and all that does is generate some information that the computer reads through to let it know that there's two motors and where they're attached to the cortex. And all of this will make a lot more sense when we actually get in the classroom and you can see what the heck a cortex is. Okay, so Okay, so I just put in this, I just copied this straight over from the assignment that I made, and I'm just going to split it into steps and write them as comments. And you'll notice that I'm just hitting enter, making the two comments, and then splitting it out. Okay, so we have move forward at full speed for 10 seconds, stop for a second, turn 180 degrees, stop for a second, move forward at full speed for 10 seconds. Okay, so I've got all the steps in. It doesn't really matter, but I can take out that those punctuation marks. I could abbreviate more if I wanted to. And now I'm just going to give myself some more space to write in my code. So move forward for 10 seconds. We've done this so many times. R127. And we're going to do the same command. And we're going to do motor L127. So that's going to start both motors. We're going to wait for 10 seconds to have them run for 10 seconds. Then we're going to stop motor R, and stop motor L. Okay, so I've got these commands already. Move forward at full speed for 10 seconds. Again, we have the second time when we have to do exactly the same thing down here. So I'm just going to go ahead and copy and paste that. So now I've got both of those done. Okay. The next part is also pretty easy. We want it to stop for 10 seconds, or stop for 1 second. Since we already have both motors stopped with the stop motor command, all we have to do is tell the program to wait for a second. So I type in my wait one. Oops, just wait one. And I gotta make sure I spell it right. You'll notice that it doesn't turn blue when I spell it wrong. Okay, so wait for 1 second. I'm gonna do another wait for 1 second. This turn 180 degrees is the one that will be new. Remember, we want one motor to turn forward and one motor to turn in reverse, and we need both motors to run for 1 full second and then stop. So I can, again, take this code, which starts both motors and stops both motors, and also has a wait command in it, and I can just copy it down here. Now, instead of having both motors start at forward at full speed, I'm going to start my motor, or my left motor, at reverse. This is going to get it to spin. I want it to run for 1 second, so I'm going to change it from 10 to 1, and then we just need to stop both motors. And that's it. You'll notice I've got all 5 parts of this program written out, first in comments that describe what I want the robot to do in human language. And then I added in the code to make it do that step in robot language. Okay, so again, we start both motors at full speed, we run for 10 seconds, and we stop them. We're going to wait 1 second before we do the next step to get everything to slow down and finally get to a stop so we don't wreck stuff or make things flip or spin or skid or whatever. We're using the same pattern where we start both motors, we wait, and then we stop both motors. This time, since we're trying to get them to spin, we're making that one side move at forward and one side move in reverse. It only takes 1 second for the robot to turn all the way around. Okay, I should say turn 180 degrees. We're going to repeat that stop command to let that robot kind of settle, then get to a complete stop before we do the next step, which is moving forward again for 10 seconds and stopping. Okay, so that's your code for today. All right, hopefully it made sense to you. It's a good idea, even if you've watched me do all these steps, it's a good idea to make sure you type it all out, obviously, so that you can get the hang of what we're trying to do. Okay, that's all, everybody.